We will wait for another 20 seconds and then we'll start our session. Okay, we will start our session. In previous session, we have learned about power transmission using flat belt drive. So we have learned about selection methodology of flat belts and associated pulleys. So now we are moving further with another power transmission device, that is V belt and V pulley. So today we are going to learn about selection of V belt and pulley. So we are going to learn the methodology of selection of V belt and pulley. And in the next session, we will take the actual problem of selection of V belt for a corresponding application. So V belt normally very rarely single V belt is used, but mostly the V belts are used in natural state. So number of belts are more than one, depending upon the power requirement and the grading of the belt. So this is a smaller pulley. This is big pulley on which the belt is mounted here. So there in this application there are three belts shown here. So on this belt you will find the nomenclature of the belt, designation of the belt here. We are going to learn how the designation is done also in this lecture. So now normally the type of drive used for V belt drive is the open type drive. Cross belt drive is very complicated to use for V belt drive. So only open quarter turn drive or open drive is used. So most of the calculation in this chapter is based on the open drive mechanism. Okay, so let's go and understand what is meant by V belt, what is the construction of V belt and V pulley, and then we will go for the selection methodology. Okay, so let's understand the meaning of V belt. The V belt, the shape or cross section of the V belt is not exactly V. Please remember, it is not exact V. It is a truncated form of V belt. So the cross sectional area is a trapezoid. So it is a truncated means it is cut from the bottom here. So this is a trapezoidal section. So this V belt is having trapezoidal section, having belt width at the top B and the thickness of the belt equal to C. So this material is made up of rubber and there are fabric material inside and the core material inside depending upon the load to be taken. This the amount of core material and fabric material will be defined. These are the two inclined edges which will be touching to the pulley surface. So they make an included angle of 2 beta. So beta is your V angle here or V pulley angle. So 2 beta is the included angle for the belt here. So this angle varies from 30 to 40. Ideally, this angle sometimes is taken around 29 degrees. So the V belt angle is around 30 to 40. So V belt is mostly used in factories, workshops for power transmission. When you are transmitting power at a shorter distance compared to the flat belt, the center distance between two shafts is very large, but the shorter distance is not that short that you cannot use gears there. So in that case, you have to go for V belt. So the center distance for this application is lesser than the brick and cord molded rubber, and inside you will have fabric and cord inside here. So they are molded in a. I have told that they are molded in trapezoidal shape, means a truncated V shape. So truncated V shape is your trapezoidal shape here. So these are particularly suitable for short drive. Short drive means the center distance between two shafts is lesser compared to the flat belt drive. It is not very short. If it is very short, then we can go for gearing arrangement. We will not go for the belt arrangement. If it is a center distance is comparatively larger but lesser than the flat belt requirement, then we can go for the V belt. The V belts are made up of endless material. They don't have end. so it is in a continuous path. So starting from one point, if you travel across that length, you will come back to the same position again. So this is an endless belt. So V belts are endless belt. Now this belt will be mounted in the V pulley. So in the next slide, we are having a diagram for V pulley. Okay. So this is the V pulley cross section here, having face width say capital B or L here. This belt is mounted here. So this is the cross section of the belt here. So whenever we mount this belt inside the V groove here, the right way of mounting this V belt in this groove is that the bottom part here, if you see here, there is a gap here. So bottom part of this V belt and this bottom surface of the V groove should not touch each other. Only the side surface should touch each other, as well as the special care has to be taken when we are selecting this groove width as well as belt width. The top width of the belt, this is the top width of the belt, so that should lie below the top surface of your V pulley. This is the top surface of V pulley, and this is the top width of the belt. So that top width of the belt should be below the V groove. Then, and there is no contact at the bottom here. There should be a gap, clearance gap here, and the contact should happen on the sides of the V here. Then only the correct belting has happened. Otherwise, it is incorrect belting. So when we are talking about V to V belting, the surface in contact in V to V belting is, that is V belt and V groove. That is called V to V belting. So in that case, the surface in contact are the angular surface of your V pulley and angular surface of your V belt. No other surface will be in contact with other than this angular surface. Other surfaces will not be in contact with V pulley or belt anywhere here. So power is transmitted by wedge. I am saying it is by wedging action between belt and the V groove in the pulley or screw. So where this wedging action is happening, this wedging action happens on this surface here. So on this wedging action here, there is a normal reaction developed on this surface here, inclined surface on this surface here. So this normal reaction will create frictional force here, and this frictional force is helpful to drive this pulley, and the power can be transmitted from a moving belt to the stationary pulley. So pulley will start rotating and the power will be transmitted. So the wedging action happens on this inclined surface here. The V groove angle is slightly greater than V belt. V belt angle is between 29 to 40. V groove angle is slightly kept greater than that, so it is in the range from 30 to 38. Then the clearance must be provided, that I am already talked. The clearance must be provided at the bottom of the groove here. This is the bottom surface of the your flat belt, and this is the bottom surface of V groove. So there is a small clearance here. So that is called a working clearance, and that working clearance has to be there. A clearance must be provided at the bottom of the groove as shown in figure, in order to prevent touching of the bottom as it becomes narrower from wear. So what is the significance of this? So if you want to identify whether your belt is weared out not, then normally we have to check the bottom surface of the belt, that is the exposed bottom surface of the belt. And if there is a wear on that bottom surface, means there is a need to replace that belt, replace that V belt. If that bottom surface is not weared out, then you can say still you can use that belt with proper care. So if bottom is weared out, then there is a chances the thickness of this belt, this here T. If I go to the here, this is the bottom surface of the belt here. The contact surface here is the inclined surface here and inclined surface here. So when they are moving relative to the pulley surface, this part will naturally wear out. This surface will also naturally wear out. Since there is a clearance here at this bottom side, there is a clearance between the pulley surface and the belt surface. So this part should not wear out. It should not wear because there is no contact. So it should not wear out. If for the usage, say for a time period of usage, these two surfaces wear out faster, then this bottom surface also start touching the bottom surface of the pulley, and that also starts wearing out. So it signals out, if the bottom surface is weared out, it signals out that you need to replace this belt. So you need to replace the set of belt, purchase new belt of standard designation and replace that. So this part is very important. So whenever the maintenance person will observe, it will not look at the side here. It will look at the bottom of the belt, and if the bottom of the belt is weared out, he will immediately replace that belt under a routine maintenance cycle. Okay, so you understood what is meant by V belt at this moment and the V pulley. So depending upon the number of belts, you will have as many number of grooves there. So the distance here, we can say this is the depth of the V groove, and this is the pitch width. If you draw the pitch diameter here for the V groove, so if you measure the width of this V groove across this pitch line, then it is called pitch width W here. So this is very important. So whenever we are doing the calculation, we are doing the calculation for pitch length and pitch width here. So belt length is also calculated in terms of pitch length. So what is the length of the belt on this surface? So that is called pitch length of the belt. Then the distance here, this is the pitch between two grooves here. So this distance is very important, because if you keep this distance shorter, so this thickness will become smaller, and there is a normal reaction coming here. So this normal reaction may break this surface here or cause the bearing failure or the shear failure of this surface. So the E value has to be sufficient. So there are the standard values available. There is a standard value available for B, and there is also tolerances available. So whenever we select the pulley, we have to select the appropriate pitch diameter, appropriate value of depth, appropriate value of E, as well as the tolerance on this value, so that these pulleys can be used effectively for power transmission. Okay, so let's go to the next process. So this is regarding the introduction of V-belt drive. So you can use single V-belt, or you can use the number of belts depending upon the power requirement of the transmission here. So now I am going step by step process of how the V-belt is selected, or once the belt is selected, what are the methods or how it is checked whether the selected belt is suitable for the application or not. So V-belt selection, first step is selection of type of belt and minimum pulley diameter. So when we select the belt, there are different types of belt material, belt sections are available, and then you have to select appropriate belt section and what should be the minimum pulley diameter in that drive. That whatever the drive we are selecting, one smaller pulley diameter and one bigger pulley diameter. So we need to define what is the minimum pulley diameter. Unless if it is not specified in the problem, you have to take that value of minimum pulley diameter from this. So for this you require input, that is power to be transmitted, how much power you are going to transmit with that drive. So you should know about this. So this can be calculated or it can be evaluated based on the application need, and this power and or sometimes if you know the motor capacity, the power rating of the motor itself is power to be transmitted. So that will become the input, and then based on this PAG 7.58 page section, this is the table available there. So based on this table, you have to select the type of belt, section of the belt. So there are the various cross section of the belt, various types of cross section. So these various types of cross sections will have a standard value of W and standard value of T. That is, W is the width of the top width of the belt, and T is the thickness of the belt. So for each section, so if you take a section A belt, then it will have nominal width, top width as 13 mm and nominal thickness as 8 mm. Okay, so this is the standard top width and standard thickness of that belt. So where we can use this A-type belt, so the range of the drive, if you have a rated power in the range between 0.75 to 5 kilowatt, you can go for the A-type belt. So you can go with a single belt if it is very low power, and if it is say high power up to say 5 kilowatt, then you can go for multiple belts. So you can select A section belt and you can select 3 or 4 belts and you can transmit that power. Now when we are selecting this power, it is recommended to use the minimum pulley diameter, that is the minimum pulley pitch diameter, small d. That small d is specified here. You cannot select lesser than this. If you are going for section A belt, your small pulley diameter should be 75. Now you may ask, sir, why we have to select this smaller pulley diameter? Because this is in a belt section having certain thicknesses. You can see this width is 13 and thickness is 8. This belt is wrapped around this pulley. If the diameter is, of that pulley is very, very small, so it is going to introduce, when it is going to wrap, say, we are going to bend that belt on that surface. So it is going to introduce the stresses. And as the thickness is more, as the thickness of the belt increases, or thickness or width of the belt increases, then wrapping becomes difficult. So as we increase this thickness, we need a larger pulley diameter. You can see the bending on larger pulley diameter is easy compared to bending on smaller pulley diameter. So if your thickness is small, then you can have a lesser pulley diameter. If your thickness of the belt is greater, you should have larger pulley diameter. So pulley diameter increases based on the section and based on thickness here. Okay. So normal, if a normal load condition is between 2 kilowatt to 75. This is very low load condition. Normal load condition, medium load condition is between 7.5 to say around 25 kilowatt, and high load condition, that is between 25 to say 200 kilowatt. So based on that, we can select the corresponding cross section of the belt, and then we can identify the pulley diameter. So here the selection of the belt type and pulley diameter. So rated power given for that drive, suppose rated power is 10 kilowatt. So if the rated power is 10 kilowatt, so the rated power of the drive is between 7.5 to 75 kilowatt, so 10 kilowatt here. So you can select a belt cross section as P section, having pulley diameter, minimum pulley diameter equal to 400 mm. Top width of that belt will be 22 mm, and thickness of the belt will be 14 mm. So the weight is also given, some because if it is high speed belt, then the weight is also important, because this will create additional centrifugal forces here. Okay, so you can go for type C belt when your power is between 10 to 15 kilowatt or 10 to 25 kilowatt. Now there you may ask, sir, C and D. Here also I can use D also. If my 25 kilowatt power is to be transmitted, somebody can select C or somebody can select D also. So it is dependent upon your variation in the load requirement of the overload consideration. If you select say B here, we can select for 10 kilowatt, you can select B section as well as C section. But if there is a chances that overloading may take place to the extent of say 80%, 90%, or above the rated power. So 10 kilowatt, 80% of that means say 18 kilowatt. Then in that case, there is a chances it is exceeding the maximum limit. So the even your section B belt, there is a chances section B belt will slip, or it may have failure in that section. And that's why if you go for say 10 or 15 kilowatt belt here, even though it exceeds the value by 100%, 15 plus 15, it becomes 30, then still section C will be safe. So when we select the type of section, we have to see my rated value is on the lower side or higher side. So 10 or 12 is on the higher side, so it is better to go for C. But if it is, let's say 5 kilowatt, here it is higher, so we can't go for A side. So use 5 is a lower here, so we can go for section B belt here for 5 kilowatt rated power. Okay, so first step is to determine the type of section and the minimum pulley diameter. So these two columns you need to read properly, and this pulley diameter you have to select here. So next step, this is the selection of the belt pulley diameter. Next step is to determine the speed ratio, pulley diameters, and center distance. Now, speed ratio will depend upon the application speed requirement and the input speed requirement. So if you take the application speed upon input speed, whether the speed reduction is required, speed increase is required, so that becomes speed ratio. And based on that, you will come to know where you have to mount exactly the smaller pulley and larger pulley, whether to be mounted on the input shaft or output shaft. If there is a speed reduction, then smaller pulley will be mounted on the input shaft. And if there is a speed increase, then smaller pulley will be mounted on the machine shaft or output shaft. So once identify the speed ratio. Sometimes this speed ratio will be given in the problem, or you have to identify approximate value of speed ratio. Then based on the speed ratio, you have to determine the larger pulley diameter. The larger pulley diameter also depends upon the center distance. It is not related only to the speed ratio. It is also related to the center distance. So larger pulley diameter, either you can select these two ratios and then you can select center distance. If there is a problem of fixed center distance, then you have to select the larger pulley diameter based on the fixed center distance. So they are interrelated. That I will show on the page number 7.61. So this data is available. So how this pulley speed ratio and pulley diameters are connected, you can see there. Okay, so this table you already seen here, selection of the V section and the pulley diameter. Then this page is not scanned properly, so no problem. I'll scan it separately and upload it. So this is okay. This is scanned properly. Now we are talking about the speed ratio. So speed ratio here and larger pulley diameter. The smaller pulley diameter D, this is selected from the earlier table. Larger pulley diameter will be equal to D into N1 upon N2 into N. So N1 and N2 are the speeds here. So N1 is the RPM of smaller pulley, N2 is the RPM of larger pulley, and eta here is the efficiency of the drive. So normally you can assume 98 or 100% efficiency. If it is known, if you know this efficiency, then only we will use. Otherwise, we will use this efficiency as 100%. So from this formula, you can determine diameter. But there is also relation between diameter and speed ratio here. Speed ratio is equal to I is equal to capital D upon small d. And for this value of I, there is a recommended value of C by D ratio. So if you have given a problem with a fixed center distance, so C is fixed there, so it is given. So because there is a space limitation, you cannot increase the center distance, say above say 1200 millimeters. So then C is fixed. So then based on this C value and I value, you have to get your D value. So these are the ratios, recommended ratios for C by D and speed ratio. Suppose speed ratio is requirement is say 1:3. So you want to say reduce by 3 times the speed. So you require 3. Then in that case, C by D ratio is equal to 1. And if your C is fixed say 1200 mm, so then your diameter is fixed at 1200 mm. And then you have to see that taking that 1200 mm diameter, your small d should not be lesser than the table value given on PhD 7.58K. Okay, so that this value, that small d should not be lesser than this value here. Even though if you go from the fixed center distance concept, if you calculate capital D first and then you calculate small d, the calculated value of small d should not be lesser than this value. It should be greater than this. So if you have selected type C belt, then it should be greater than 200 mm. If you have selected type B belt, then it should be greater than 125 mm. So I think you understand the calculation of pulley diameter, both smaller pulley diameter as well as larger pulley diameter, and the speed ratio, the concept of speed ratio, the relation of speed ratio with a center distance. This is the speed ratio, a relation with center distance. So many times there is a fixed center distance, but there are chances when if you are designing new machine, then the center distance is a choice of designer. So you can have variable center distance or adjustable center distance there. Okay, so let's go to the next step now in the presentation. So okay, so you can calculate speed ratio. You can determine larger pulley diameter in both ways based on the fixed center distance or approximate center distance. So this is done from the page number 7.61. So next step is step 3, determination of pitch length of the belt. Or if you know the standard belt length, then you can determine the center distance for that drive. So normally if fixed center distance is there, you have to go for pitch length calculation. And if you can vary the center distance of the belt, shaft, then you can go for standard pitch length of the belt and you can calculate center distance required for that drive. So that I have written here. Calculate the pitch length based on approximate center distance and pulley diameter. So if you know the center distance data and pulley diameters, you can calculate pitch length. or calculate the center distance. Calculate the center distance of the drive for selected length of the belt. If the standard length of the belt is already selected, then for that you have to calculate the what should be the exact center distance. Adjust. So there are some drives they are having adjustable center distance mechanism. So you can adjust the center distance to meet that requirement. So this is to be done from PAG 7.59 to 7.61 pages. So how we are calculating that I am demonstrating here. So there is a formula available for calculating the pitch length of the belt. Okay. So this is the formula. Yes. Okay. The pitch length of the belt, L. Pitch length of the belt, L is equal to 2C plus pi by 2. Here it is multiplication, it is not plus. Pi by 2 into D plus D plus D minus D bracket square upon 4C. Please make this correction here. Here there is this plus sign is not there, it is multiplication sign. So if you know the center distance, so you can put it here. You know the pulley diameter, bigger pulley diameter, smaller pulley diameter, you can put it here, and you can calculate the pitch length requirement. You can see in this formula, L is the nominal pitch length of the belt and to be selected from the table. Okay. If you are calculating center distance, then you should know the L, and capital D and small d, and then you can calculate the center distance by this formula. C is equal to A plus A square minus B, where A is this L by 4 minus pi into D plus 8, or B is equal to D minus D square upon 8. यही formula they have rewritten in the simpler form to determine the center distance if you have selected the standard length of the belt. Or if you have fixed center distance, then you can calculate the pitch length required by this formula. Now, once you calculate this pitch length, next step is to determine the designation of the belt. Okay, so let's go for the designation of the belt and next point in this presentation. So you have calculated now. You can calculate based on the center distance. Suppose if you have calculated pitch length, so next step is to select the right belt, designation of V belt. So for that we are using IS Indian Standard 2494 table. So here the few tables are available, not all tables are available. So here input required is calculate pitch length with or without consideration of initial tension. So I am already shown the formula to calculate the pitch length. So that is the standard pitch length, say calculated pitch length. If you are considering the initial tension, then the pitch length has to be decreased. How much it has to be decreased? That is also given on page number 7.61 that I will show here. Okay, so you are calculating the pitch length required here by this formula. Now, once you calculate this pitch length, this is the nominal pitch length required here for the belt. But you have to create initial tension while wrapped around the belt. So you have to create initial tension. Then this length has to be shorter. So how much shorter? It is given here. For initial tension, in order to give initial tension, the belt may be stretched to 0.5 to 1% of the length. So this length can be stretched by 0.5 to 1% of the length. So when we are selecting this length, you can take what is required final. Suppose if you require say 1550 millimeters as a length. So you can decrease while selecting the belt. You can take a shorter one. How much shorter? Maybe by 0.5% or 1% maximum. So if it say 1%, so you can select a belt of 1% means around 15 mm short. So 1550 minus 15. So I can select a belt of 1535 millimeters. So you can select a pitch length of the belt around 1535 instead of 1550. So that is the meaning of considering initial tension. If you don't consider initial tension, then whatever comes by this formula, that becomes the standard value. But in a practical application, we have to consider the initial tension. So you have to shorten this length by at least by 0.5%. And in some cases, you have to shorten this length by 1%. So this we have done. This exercise can be done using 7.61 page. So you have completed this calculation with or without. So without means only formula. With means formula plus reduction in the length. So then there are the standard pitch length. So these tables are available on 7.59 and 7.60. So I'll show one such standard. Let's go to the 7.60 page. Okay, this is page number 7.60. Suppose I select a cross section C. Okay, so for this cross section C, say this is 3104. This is called standard nominal pitch length. So this is a standard pitch length. 3104 is a standard pitch length. So this is a belt having cross section C having length 3104 mm. Standard pitch length of 3104. For this belt, nominal inside length. So 3104 is your pitch length. Inside length will be lesser than this value. So inside length of the belt, inside length, that is the bottom surface of the belt, having, if we measure that length along that surface, so that length is 304. So this nominal inside length of the belt becomes the designation of that belt. Please remember, nominal inside length of the belt becomes the designation of the belt. So for section C having 3104 pitch length, then 3048 is the designation of that pole. 3048 is the designation of that belt. So this 3048 is the designation for the pitch, inside length of the belt. Now then there is a concept called rating of the belt. So I'm rating start with 50 number. Either the rating will be greater than 50 or lesser than 50. So let's see this belt, how it is designated. So you have to select the standard pitch length, and then from that standard pitch length, designation with the help of nominal inside length. So nominal inside length was there 3048. So the designation becomes 3048. Now the rating value is calculated as below. You will use rating value of 50 if your calculated pitch length is equal to the standard pitch length. Suppose your standard pitch length is say 3104 and you have calculated L and that has come around 3104. Then your rating of the belt required is 50. The rating of the belt is required 50. Suppose calculated length is other than standard pitch length, then the rating is calculated by this formula. Rating is equal to 50 plus plus calculated pitch length minus standard. Here the lengths are in millimeters. So this 2.5 is also in millimeters. For each step of 2.5 millimeter variation in the length, rating value of 1 will be added here or deducted here. If your calculated pitch length is greater than the standard pitch length, that 1 value will be added here if it is greater than 2.5. If this calculated pitch length is less than standard pitch length, so this negation will come. And if this length is lesser by say 2.5 mm, so the factor of minus 1 will come here. So rating will be minus 1, minus 2 will come here. So rating will be 49, 48. So the rating will be 48, 49, 50, 51, 52. So the ratings are available up to 45 on the lower side, and on higher side the rating of the V belt is available up to 55. So when we designate a belt here, suppose if I designate this belt, say if we go to this slide here, suppose the designation of this belt is 3048 dash or forward slash. What is the designation? Suppose it is calculated length is say lesser by 5 mm than this value, then the rating will be 48, because less than 2.5 mm short means one rating less, and if it is exactly equal to 3104, then rating is equal to 50. So instead of 50 we will go for 48 there if it is lesser by 5 mm. Suppose this calculated value here is greater than 3104 by say 5 mm, then the rating will be 52, because 2.5 plus 2.5 becomes 2 rating above. Then the standard rating is 50, 50 plus 2. So then the 3048 slash 52 will be designated as the belt. So this designation is also explained in here. I'll show here. Designation, how it is designated. V belt cross section C having nominal inside length वही मैंने लिया अभी 3048. So 3048 millimeter in terms of inches it is 120 inches, If you are using, say, SI unit, then it is 3048. If you are using metric system, then it is 120E. Shall be designated as, the designation of that belt is, uh, first letter is your section, type of section C. Then there is a your pitch length, nominal inside length. Nominal inside length is 3048. Or if it is mentioned in metric, then it is 120. Either of this value will be mentioned. So this is as per IS 2494. The belt should be stamped with grading. So this belt will be stamped with grading number 50. So this grading number or rating number will be 50. So it will be written as C3048 dash 50. It will be written as C3048 dash 50. So this is a belt having standard rating of 50, having inside nominal length as 3048 and pitch length of 3104. Pitch length of 3104 mm. Now, if there is a deviation in the calculated pitch length other than 3104 mm, a deviation of 2.5 mm in length for nominal pitch length to be represented by 1 unit. So rating will be either increase here or grading will be decrease here for every decrease or increase in the 2.5 mm length of the belt. So here one sample is mentioned here, represented by 1 unit, and the grading number will be increase or decrease as the length is more or less. Suppose there is a belt designation C3048. So this is the nominal inside length, 120, having 2494. This is IS standard 2494. Having an actual pitch length is 3104. Then it is designated as C3048 dash 50 because 3104 is your pitch length, calculated pitch length, and the standard pitch length is also 3104. So there is no difference. So then the grading is 50. So dash 50 will be mentioned here. If the actual pitch length, say, is 3101, by how much? It is short by less than 2.5 mm, but not greater than, say, 5 mm. So in this case, the designation is C3048 will remain as it is, and it will be mentioned as dash 50. It will be mentioned as dash 50 here. Dash, it is shorter, so it will be reduced by grading value. Since it is less, the greater than 2. The reduction is greater than 2.5, but less than 5. So reduction in it is by one grading. One grading instead of 50, the grading will be 49. Another example here is if the actual pitch length is, say, 3109. If actual pitch length is 3109, it is greater than 3104. So grading will be greater than 50. But it is not greater than 5 mm. So grading will be only greater by 1 unit. So or approximately around 2 units. So 9 means are almost, say, 2.5 plus 1.5. So it is approximately around 5 mm increase. So in that case, you can rating this belt as C3048. This will remain as it is. Dash 52. Dash 52. That is the additional 2 grades will be added there. So your belt becomes C3048 dash 52. And this rating is printed on the top surface of the belt. Please remember, these ratings are printed on the top surface of the belt. I'll show the diagram for that also, so you can see here. Okay, whatever the designation mentioned here, it's mentioned on the top surface here. The belt designation having type of section, whether it's A, B, C, D, E, then followed by nominal inside length of this belt. What is the nominal inside length? If it is mentioned in millimeter, so it will be mentioned in millimeter. If it is metric system, then it will be mentioned in inch. Dash 50, dash 49, dash 48, dash 55, 52, dash 53, dash 51 will be mentioned there. So that indicates the grading of that belt. So when we select the belt, we have to calculate the designation of the, we have to write down the designation of the belt as well as the grading of the belt. And if you go with this designation into the market, you will get the belt. Otherwise, the suppliers or manufacturers will not give you the belt. They will ask this what is the designation of your belt. So you can buy that and come back to the workshop or industry, and you can fit that belt properly. Otherwise, the fitting of the belt will not take place properly. So this is very, very important, understanding the designation of the belt. That is very important. So once you understand this designation of the belt, then the next design process is very simple. Okay, so let's go to now presentation here. Okay, so we have completed now designation of the belt. How the designation inside length is considered as a designation, either rating of 50 or plus minus grade. So that will be calculated by this formula. Next is to calculate the power rating of the belt. This is very similar to the power rating of the flat belt, but there are the standard values. Here the formulas or tables are given based on the selection of your type of belt here. So power rating of the V belt, either you can use formula. So formula, these are the formulas available for calculating the power rating, or you can use the table value based on your belt speed and the pulley diameter. So the table values are available from page number 7.60 to 7.67. So power rating from table values based on the belt speed and equivalent pulley pitch diameter can be calculated from can be taken from this. So if you want exact power rating, then you have to go for this formula. So in this formula, there are various terms. This kilowatt is the power rating of the belt section. Yes, here is the speed. Yes is the speed in meter per second here. This is the DE. D is the equivalent pitch diameter. Your smaller pulley diameter is DP or D, small d, pitch diameter. That pulley diameter will be corrected by a correction factor. That pulley diameter will be corrected by a correction factor by multiplying by the correction factor. So you will get the equivalent diameter D. D is equal to correction factor into pitch diameter of the smaller pulley. So by using this DE and the belt speed will come from the application. What are the speed of your shaft and what are the pulley diameters, the RPM of the pulleys. You will get the belt speed in meter per second. And from this, you can calculate the power rating of single belt. This is the power rating of single belt. So if you want to transmit larger power, then you have to use the number of belts. To identify the number of belts, you need to know what is the power rating of single belt. Now this D, D in this formula, here it is mentioned, the D maximum value, this formula can be used for maximum value of D up to 125 mm. This formula will be used for maximum pulley diameter up to 175 mm. This formula can be used up to 300 mm. This formula can be used up to 425 mm, and this formula can be used up to 700 mm. How this D is calculated, that is given in the page number 7.62. I will show there. This is the formula available for power rating based on your section. You can calculate this power rating by using this formula. In this formula, you require DE. So this DE, you can see here DE is equal to equivalent pitch diameter, that is equal to pulley diameter, smaller pulley diameter into FB. FB is the correction factor, smaller pulley correction factor. So smaller pulley diameter correction factor FB is given in this table. So based on your speed ratio I, based on your speed ratio I, that is our speed range ratio diameter by small d ratio, these correction factors are applied here, and from this we can get D and you can use this. Or you can use, instead of going for this much calculation, you can make your simple calculation for each belt. Say this is section A belt. For each belt, for corresponding values of belt speed and different values of approximate value of pitch diameter, power rating of single belt is tabulated here. So this is for section A belt. Another page will be for section B. So these tables are available up to section E belt. So you can do either calculation or you can refer this table. These are the table available, standard table available. So you can use standard table or you can use the formula. So that completes your power rating for single belt. Okay. So let's go to the now calculating the number of belts. So here we have calculated the power rating of single V belt. Next step is to determine the number of belts here. Okay. So before determining the number of belts, you need to determine the angle of contact on smaller pulley and the associated correction factor for arc of contact. So this angle of contact, considering open drive here, it is similar to your flat belt mechanism. So same formula will be used here, and you have to use correct correction factor for angle of contact, which will be used in this formula. Okay, you have to choose the correction factor based on this angle of contact theta, whatever value you are getting here, you have to use that FD value here, this FD value here. Okay, so the final step is to determine the number of belts. To determine the number of belts, we have rated power into FA correction factor for industrial, that is called service factor, load factor, whatever the terms we can call it is called FA, upon power rating of the single belt into FC, correction factor for the pitch length, and FD, this is the correction factor for your angle of contact. So P is the power rated power of the drive which we are transmitting given in the application. FA correction factor based on the industrial service. So there is a table available for correction factor on page PHG 7.69. We are going to see this page also. Then power rating, right now in the previous step we have calculated power rating for selected single V belt based on the type of section. So for that you are using the pages either by for calculation you are using 7.62. If you are using table value, then you are using 7.63 to 7.67. Then FC, correction factor for pitch length, which is available from page number 7.50 to 7.60. And correction factor for arc of contact, which is available on 7.68. So let's see where this FA, FC, and FD is given in the PHG data book. I will show there. Let's go for FA first. Okay, this is the correction factor for FA, that is the service factor we call it is our load factor. So the load factor or service factor depends upon your driven characteristics and driver characteristics. So driving characteristics are in the columnar form here, and the driven characteristics where we are having application, so that is called driven characteristics. Application characteristics is on the rows, in the rows. So you have to identify what is your driven characteristic, what is your driver characteristic. Then you have to select once you identify that, you have to select the service time, how much long it is going to be used, whether it is for single shift, two shift, or it is continuous use. So single shift, two shift, and continuous use. So based on that, you can select your service factor. This is very big table is available based on your machinery, and the service factor can be selected here. So this is FC, FA. Then you have to select FC. FC is available. Now this is FD. So angle of contact will be selected, and then you have to find out the correction factor for angle of contact FD. Again, this angle of contact depends upon type of contact here. I have told the V to V belting and V to flat belting. The meaning of V to V belting, we have V belt, V pulley. We have V belt and flat pulley. Okay, so this arrangement is V belt, V pulley, and this arrangement is V belt, flat pulley. So if you are having say angle of contact say 160, then the correction factor for V to V belting is 0.95, and for V to flat pulley it is 0.8. So depending upon the drive mechanism, pulley surface, V surface or flat surface, the correction factors will be applied. I was discussing about the placement of the belt in the V groove. So here there are the three methods are given here. This is incorrect method. The reason is that the top width of the belt, this top width of the belt is above the belt surface, pulley surface, which is not recommended. It is not recommended. So this type of belting is incorrect belting. Then we have another here. The top width is below the top surface of the pulley, the top width of the belt is below the top surface of the belt, or there is a chance that this surface may touch to this surface here. This is also incorrect pulley, belting. This is also not recommended. This is incorrect belting. What is correct belting? Whatever we select the top width, this is the top width of the belt, and the top width of the groove should match exactly. And there should be a sufficient clearance at the bottom. There should be a sufficient clearance at the bottom. Then this belting is called correct belting. So this is called ideal belting condition, but it is not necessarily every time you will get the ideal belting condition like this. You may get either of this belting condition, either this belting condition or this belting condition. This is not acceptable at all. The surface above the pulley surface, this belt width above the pulley surface is not acceptable at all. This is acceptable to some extent. This is acceptable to some extent. So you should have either this arrangement. If this is not possible, then this arrangement. But this arrangement is not acceptable because this will cause uneven wear on this inclined surface. Why it is not acceptable? When it is making a contact, it is not making the contact for the entire inclined length. This belt is making contact for a very lesser length here. So the part here will wear out faster. This part will not wear out. So since the contact surface is less, the bearing pressure will be more, reaction will be more, and that will cause the wear of the surface faster here. In this case, you can see here, this entire length is in contact with this. Here also, this entire length is in contact. So when the wear is happening, the wear will happen on the entire surface, and the bearing pressure will be distributed uniformly, approximately uniformly. It is not uniform distribution actually, but it will be approximate uniform. Here it is uneven in distribution. So these two beltings are recommended here. So this is regarding the belting arrangement and the belt correction factor, angle of contact correction factor. Then one factor, that is FC, is left out. That is for pitch length correction. So that is available in the pitch length table. Here. This is your pitch length table. That is 7.58 to 7.62. So here the correction factor for FC. This is the correction factor FC. Belt length correction. If your belt is C, then this column to be followed. If your belt cross section is B, then this column to be followed. So depending upon the selected correction factor will be used, and that will give you the exact number of belts required here. You will get the exact number of belts required here. So if you come back to the presentation here, so number of belts required here, rated power into FA upon kilowatt, rating upon FC into FD, you will get the fractional value here, and this fractional value will be converted into the whole figure on the higher side. So if you get here 2.4, then the number of belts you have to use here. If you get here this calculation, number of belts say 2.4, then you cannot go for 2, you have to go for 3 belts of that cross section. So that completes your belt selection, and then finally based on that belt, you have to determine the dimension and tolerance on the size of the pulley. So for that you have to determine what is the pitch width of the pulley and the face width of the pulley. So that I am showing in the PhD data book, that diagram also. Yes. This is your pulley cross section here. Pulley face width is real here. This is your pitch width of the pulley. This is your pitch diameter of your pulley. So this is called the pitch width, groove width here. And center distance to this center distance is called the pitch of the groove. So this is the pitch of the groove between two grooves, and this is the pitch width. So what are the tolerances on this pitch groove? What is the tolerance on the pitch width? What is the tolerance on the total width of the pulley, depending upon the number of belts? If you are having 3 belts, then 3 such grooves should be there. If you are having say two belts, then 2 such grooves should be there, and accordingly you can determine the L required based on this RE value for various sections. So you can see in this table here, this is a horizontal table. So you can see here what type of cross section you are having. Take section A. Then what is the pitch width for section A? 11 m. This is the pitch width required at the pitch diameter for the pulley. Minimum distance below the pitch line, whatever the designations are given. So then based on this, there are the tolerances on certain parameters. So these tolerances are there. And then based on this, you can write down the sizes and dimensions of V pulley. So that completes your selection of V belt and V pulley. So this is the standard procedure to be followed. So in the next session, I'm going to solve a problem using entire this process. Okay. So if you have any doubt on this process, you can ask by unmuting. So I have completed the presentation from my side. So if you have any doubt, you can ask here. You can unmute and ask the doubt, or you can put into the chat box also.